So kind of a geometry review day, distance, midpoints, and circles. I've put in front of you the distance formula and the midpoint formula. This should all be a review from Algebra 1 and both geometry. Distance formula, given 2 points of x and y. We have a first point and a second point. And you want to find the distance between those 2 points, assuming it's not vertical, in which case you can just count. There are your 2 formulas. Likewise, if I want to find the midpoint, you're taking the average of the 2 x points and the average of the 2 x points to get the midpoint. So just a quick review of how to do both of those. We're going to find the distance here. So let's go through. We'll call this point A and B, and we're doing this. And so I'm going to go b minus a in each case. So the distance is equal to the square root of 7 plus 5 quantity squared and negative 2 minus 3 quantity squared, or 144 and 25, which in this case is, what is that, 169, and what do you know, this comes out clean, all right? Which isn't always going to be the case, but it did in this case. So now if I want the midpoint, basically I'm going to take the average of the x's, average of the y's, so I have 3 minus 2 over 2, and negative 5 plus 7 over 2, which gives me a half and 1. And that's about all the review you're going to get, because most of those problems are just plug and chug. Okay, so let's go back to geometry. Talk a little bit about circles. If I have a circle and it's centered at the origin, so it's 0, 0, and it has some radius r. The equation for this, if you remember, was x squared plus y squared equals r squared. And in this case, this looks to have a diameter, or a radius of 4. So for this specific triangle, it would be x squared plus y squared equals 16. Now, in this case, here's 0, 0, and our center is right here. All right. So for argument's sake, that's 4, negative 3, right? In general, we would call this some HK point. So we've seen HK before. Those talk about translations. So if I wanted to translate the center, basically equation in general form, x minus h quantity squared plus y minus k quantity squared equals r squared. This particular example is x minus 4 quantity squared plus y plus 3 minus a minus squared is equal to radius, I believe, of 2, so 4. All right. And let's go to another problem where we're told to write the equation of a circle having center 4, 6 with a radius of 12. This really is kind of a plug and chug situation. So let's say there's our circle. Let's say this is 4, 6, and we draw this radius out of 12. That's just straight plug and chug, so x minus 4 squared plus y minus 6 squared equals 144. That's all there is to it. Can't get more simple than that, actually. So in this case, we're asked to write an equation of a circle where we have the diameter endpoints. So in this case, let's say we've got some circle as such. We have a diameter. Let's draw it something like, something like this, roughly. All right, where we know that, let's say this is 5, 12. This is negative 13 and 2. And we have to write the equation, which means we're going to have to find that midpoint first. Well, the midpoint of this diameter will help us get the radius, right? So if I can find that midpoint, that's a start, because then I find my center. So let's find the midpoint by taking the average. So we have 13, and it's a negative. Add 5 to it, put that over 2, and take 12, add 2, put that over 2, and this is the midpoint, which is really going to end up being the center of our circle. All right, this goes to 7 over 2, and this is 7. All right, so this is our center of the circle. We can find the radius by finding the distance from the center out, or we could find the total distance of the diameter and divide by 2. It really doesn't matter. You know, it might be easier to do that since we have a fraction as the radius. So let's do this. We're going to go the diameter distance over 2 equals r. So in that case, we will take the difference of the x's, so 5 plus 13 squared, add that to the difference of the y's, or 12 minus 2 squared, and we're going to square root that. That's going to be 18 squared, which is 324. Oh, and we're going to add 100 to that and square root it. So the square root of 424, and then we take, this is the diameter, and we're going to divide that by 2 to get the radius. And then we're going to write the general equation. So let's do that. We have a center of 7/2 and 7, so x minus 7/2 squared plus y minus 7 squared equals the radius, which is this guy, squared. So that's 424 over 4, which is going to reduce to, I believe, 106. 7 squared is 106. So we're good. Next, we want to find the center and radius of this circle. Well, this looks nothing like the equation that I just wrote. But if you look back at that equation, and let's go back to those guys right here, all right, you'll notice this general equation has perfect squares in it. And if you look back a week or so, things with perfect squares that didn't exactly have perfect squares to begin with, we used a technique to get those perfect squares called completing the square. And that's what we're going to do here. We're going to take and isolate the x's and the y's on one side of the equation and put the constant on the other side. We're going to take half of each x and y's middle term and square it. So I take 6 over 2, square that, get 9. I'll write it in blue because it's new. Then we'll take half of 8, square that, and that's 16. Whoops. 16. And now, if we've added 16 and 9 to this side, we have to add 16 and 9 to this side just to keep the equation balanced. So now notice we have a perfect square. That's just x minus 3 squared plus y minus 4 squared is 13. So center is 3, 4. And the radius, remember this, is r squared is equal to the square root of 13. All right. Last example. So we want to write the equation of a circle whose center is at 5, 1. So let's call this guy right here roughly 5, 1. All right, and the circle is also tangent to the line y equals, or I'm sorry, x plus 3y is equal to negative 2. Well, if that's the case, then I better get an idea of what that line looks like in slope-intercept form. That's usually where I go. So I've got 3y equals negative x minus 2, and y equals negative 1/3 x minus 2/3. So roughly, if I want to draw a tangent line, this is just going to be an iffy thing. It's going to be a negative sloping line that has a y-intercept of 2/3, and it's going to be tangent. So it's going to be something like this, rough. And I'll just extend this line a little bit, like so. All right. And I need to write the equation of this. Well, writing the equation, I can actually start it. Not too difficult because I know the center. So I know in the end I'm going to have x minus 5 squared plus y minus 1 squared equals, and now all I need is r so I can square it. Well, to find r, I'm going to have to find the radius of this circle, and all I know is that this guy is tangent. Now we have to go back to geometry again and say, well, hey, I remember from geometry that from the radius to the point of tangency, I have a perpendicular. So then I know that this green line, how do I want to notate that? Let's go, this line, I'll go up here, has an equation of y equals, the slope is going to be the opposite reciprocal of this guy, and this has a slope of negative 1/3. So this is going to be 3x plus b. I'd need to find the y-intercept, and that's possible because I have the 0.51 that goes through the green line. So 1 equals 3 times 5 plus b. Negative 14 is equal to b. And y equals, let's see, positive 3x minus 14. So I have this line. Now, we're going to cheat a little bit because that's all we can do at this point. The only way to find this point right here, because this is what we're going to need, is to do a substitution and find out where these two intersect. So it's kind of cheating because we haven't got the two variable equations, but this is going to be the way we're going to have to do this. So let's go 3x minus 14 is equal to negative 1/3 x minus 2/3. Multiply both sides by 3, I get 9x minus 42 equals negative x minus 2. Then I get 10x is equal to, hey, this is going to be actually kind of nice, 40, and x equals 4. Once I have x, I can plug back in and find y. So let's say y equals 3 times 4 minus 14, and y equals negative 2. So therefore, I know that this point right here is the point 4 and negative 2. If I have 4, negative 2, and 5, 1, I can find my radius. So let's go ahead and do that. All right. We're going to take and find the distance then between this center point and this point of tangency. I'll take the difference of the x's, so that's 5 minus 4 squared, plus 1 plus 2 squared, square root it. This is going to be my r. Actually, if I square both sides, I get r squared is equal to 1 plus 3 squared, or 10. And I pop 10 right there, and I've got my answer. So we had to cheat a little bit to do it, but that's how we get through this. Okay, a lot of geometry review in that problem. All right, and that's all we've got for today. We'll see you next time.